Hi there, glad you're along with me. We're going to be focusing on a little bit more complicated derivatives in this video. We've just been using the power rule along with a few other basic rules so far for differentiating. And now what we're going to do is we're going to learn the product rule, and then in the next video we're going to learn the quotient rule for doing derivatives. And you can see the goal here is that you're going to learn to use the product rule. And what are you going to use the product rule for? You're going to use it to find the derivative of a function that's written as a product. To begin, let's talk about what the product rule is. I've already mentioned it as a rule for finding derivatives for functions that are written as a product, but here's a more formal definition. Let's suppose that you have a function f of x that is written as the function of two other products, u of x times v of x, the product of two other functions, u of x and v of x, such as this. F of x is equal to e to the x power times x squared minus 4. Now this is your u of x right here, e to the x power. Your v of x would be x squared minus 4. And so you have this single function that's written as a product of two other functions. Or you could just say it's written as a product because you understand that's what that is, right? So in the instance where you have that function that's written as a product, then here's how you find its derivative. F prime of x would equal u of x times v prime of x plus v of x times u prime of x. Now that might look a little complicated, so I'm going to try to make it look a little simpler. Let's just simply say that the two functions u of x and v of x are just functions 1 and 2. It's the way that I learned this. The rule then for finding the derivative of that function can be this. It could be 1 d2 plus 2 d1, meaning the first function times the derivative of the second plus the second function times the derivative of the first function. So for example, to find out the derivative of this f of x that I would have right here, I'm going to take the first function and multiply it by the derivative of the second function. Now that means I'm going to take e to the x power, and then I'll take the derivative of the second function, x squared minus 4, and the derivative of x squared minus 4 is just 2x. Okay, there's my 1d2. And then I'll put an addition sign. And then I'm going to do the second function times the derivative of the first function. So the second function there was x squared minus 4, and then times the derivative of the first function. Now, the derivative of e to the x happens to be e to the x. You know that, of course, so it might not look different. But here's my 2d1. We found the derivative. The last thing you do is you try to clean it up a little bit. Now, for instance, I can write this first product here as 2x e to the x power. Didn't write that exactly the way I meant to, though. 2x e to the x power, and then plus x squared minus 4 e to the x. I'll still leave that the way that it is. And then, this is something that you don't have to do, but it's optional. Often it's helpful if you'll go ahead and find a common factor in this sum and then rewrite this function again as a product. And the common factor, of course, would be e to the x power for these two products right there, these two terms. And so we could write this as e to the x power times 2x plus x squared minus 4. And then you can just go ahead and combine this, simplify whatever is in the parentheses if it's possible, after you factor out the like term. And I would, in this case, not really be able to simplify anything, but I could rewrite it in descending order, that polynomial, e to the x power times x squared plus 2x minus 4. All right, so the way you find the derivative of a product is you multiply the first function times the derivative of the second, and then add the second function times the derivative of the first. Let's see another pair of examples. You see the directions for this next example are to find the derivative of the function simply, and it tells you that the function f of x equals 3x minus 2x squared, that difference times the sum of 5 and 4x. So here's our function that's written as a product. And if you want to put this kind of in terms of the rule that we gave you, we could say that this function, that first factor, we'll call it a function if you want, would be your u of x, And then the second factor, whoops, didn't mean to do that, I meant to use a highlighter. The second factor or function would be your v of x. All right? Or if you want to put it in the terms that I was just saying a second ago with the numbers, there's your 1, and there's your 2. And we're going to go ahead and use that rule that I just told you, 1d2 plus 2d1, all right? Or u of x times v prime of x plus v of x times u prime of x. Now let's do that. So we're going to say that f prime of x is equal to, and we're going to start with 1d2. And so for the 1 part of that, we're just going to rewrite the first function, 3x minus 2x squared. And then we're going to multiply that by the derivative of the second function. And the derivative of 5 plus 4x is simply 4. And then we'll put our addition sign. And we'll go ahead and go with 2d1. And for the 2 part, we just write down the second function, 5 plus 4x. And then we'll multiply that by the derivative of the first function. The derivative of 3x minus 2x squared would be 3 minus 4x. Okay, so now we've found the derivative, and the rest of what we can do is merely superficial. If you wanted to, you can go ahead and do the multiplications here, and of course, with 3x minus 2x squared times 4, you would get 12x minus 8x squared. And then you could go ahead and do the second multiplication, 5 plus 4x times 3 minus 4x, and that would give you 15. And then, let's see, minus 20x plus 12x, so minus 8x. And then minus 16x squared. And then there's no common factor for all the terms like we had in the last example that I did for you, but we can combine some like terms and go ahead and write this as a polynomial in simplest form, or in descending order is what I really meant to say there. So we would have negative 24x squared from your 2 quadratic terms, and then 12x minus 8x would give us plus 4x, and then you got plus 15. All right, so you now know how to use a product rule. I just want to do one more example of this, but I hope that you're finding the concept pretty simple to use, because it really is a very simple concept. So let's use the product rule to go ahead and find the derivative of the function g of x that you see. And you already know we're going to do 1d2 plus 2d1. So let's go ahead and do that then. We're going to have g prime of x is equal to, and then for our 1d2, let's go ahead and write down this first function, 4e to the x power. And then let's multiply that by the derivative of the second function. Now, of course, the derivative of 1 is 0 because it's a constant. And remember, the derivative of ln of x is 1 over x. And since you've got the subtraction sign in front of it, we could say the derivative of that entire second function is going to be negative 1 over x. And then we'll put plus the second function, 1 minus ln x, times the derivative of the first function. And of course, the derivative of 4e to the x is still going to be 4e to the x power. So there is the derivative. We're going to see if we can rewrite this a little more neatly at all. And you're going to notice, as with a couple of examples ago, that the 2 terms that we've created do have a common factor. And so we're going to go ahead and factor that out to make this look a little bit neater. We'll bring a 4e to the x to the front, and that'll leave us with negative 1 over x plus 1 minus ln of x. And there's really nothing you can do to make this grouping here in the parentheses any neater, so we're kind of done. Excellent. So now you know how to find the derivative of any function that's written as a product. And it's as simple as that, guys. Thanks for your attention. Watch the quotient rule video next.